Hello and welcome to this series on Windows Phone 8.1 development for absolute beginners. My name is Bob Tabor, and for the past 12 years I've created screencast training just like this for topics related to C#, .NET, Visual Studio, ASP.NET, and a lot more on my own website, www.learnvisualstudio.net. This is the third time that I've been invited by Channel 9 and by the Windows Phone Developer Platform team to create this very series. So based on what we've learned from the previous two editions of this series, we've put together lessons that are focused on a gentle introduction for absolute beginners. So, if you're already an experienced software developer, you've been building apps for quite some time in .NET and Visual Studio, then honestly, you're probably going to find the pace that I move forward with rather slow. There are probably better resources that are available for you on Channel 9 and on MSDN that are more suited for your skill level. But if you're just getting started, then this series is for you. In this series, we're going to start by learning about XAML, which is the declarative language that's used for laying out the user interface for phone apps and for Windows Store apps, as well as we'll learn about the phone's API, or in other words, the specific classes and methods that are available for you so that you can interact with the phone's hardware capabilities. We'll also learn about tools in Visual Studio that will help make your job easier, like the project and page templates and like the emulator. And this time around, I'm going to focus especially on the pre-built page and project templates that are available in Visual Studio that are designed to help you become productive very quickly. The better that you understand these project and page templates, what they do, not only will you have an opportunity to see the basic implementation of important phone app features, but you're also going to be equipped to leverage these templates to build your own cool apps very quickly. And so we're going to be building several complete apps in this series, albeit small apps, but my aim here is to show you how to combine several ideas that we'll discuss independently and how to combine those together into an app that you can sell on the phone store or give away for free if you want. In fact, I'm going to demonstrate how to build universal apps. In fact, everything that you learn in this app will allow you to build both phone and Windows Store apps. So the idea here is that you'll be able to develop one code base and with a few tweaks to your code to account for the differences in form factor and the hardware capabilities between the phone and the Surface and the Windows desktop and so on. With those small tweaks, you'll then be able to sell your app in 2 stores instead of just one. So my goal for this series is to give you the definitive head start. This won't be the only resource that you'll ever need, the only instructional video series that you'll ever need in order to build phone and Windows Store apps. However, it should help you get up to speed very quickly and so that you can move on to even more advanced ideas and dive deeper into the phone's hardware. Now, before you begin, there's really only 2 requirements before you start in the next lesson where we build our very first phone app. First, you should already know C#. In fact, this series assumes that you've already watched my Absolute Beginners for C# Fundamental series on Microsoft Virtual Academy. I think it's also hosted out there on Channel 9 as well. And if you're not familiar with C# already, then please put the series on the back burner for just a day or two. Watch the C# Fundamentals for Absolute Beginners series first, and then come back to this one after you're finished there. The second requirement is that you have the tooling installed for Visual Studio for the phone 8.1. In other words, you should be able to go to File, New, Project, and then in the New Project dialog under Templates, Visual C#, Store Apps, you should be able to see a Windows Phone Apps section that would allow you to create a blank app, a hub app, and so on, and a WebView app. All right. And if you don't have that tooling installed, then please make sure that you complete that step first. Now, unfortunately, I can't help you with this. There are really too many versions and too many editions of Visual Studio and too many potential issues that arise during installation. If you need help, I would recommend that you visit msdn.microsoft.com/forums and you should go to filter by Windows Phone Development, and maybe even filter by tools for Windows Phone Development to help filter it down to just those questions and answers that have been asked on the forums by people who had difficulty in getting the tooling set up. All right, and somebody there will be willing to help you. Now, if you have any questions specifically about what I talk about in this series, then I would be glad to answer your questions or help you any way that I can. There should be a comments area below every video that is streaming on Channel 9, and I try to keep up with those comments. Also, feel free to tweet me or follow me on Twitter at Bob Tabor, and I'll help if I can. Now, please keep in mind, if you do want to ask a question, you might be asking months or even years after I recorded this video, so please try to be as descriptive as possible. Help me help you. Include the video title and the exact time marker and a little background description of what you tried and what issues that have popped up. All right? But developing apps for the phone is a lot of fun, and it's pretty easy once you get the hang of it, honestly. Make sure that you pause and rewind these videos as you're watching them. Most importantly, make sure that you follow along with the code that I write to make sure that these ideas get cemented in your mind. Following along and writing the code that I write is easily the best way to learn. Now, I'm also going to make the source code available as well as the assets that I use, so any icons or pictures or videos or audio files, you'll be able to download those as well and follow along with whatever I do in the videos so that you can check your work against mine. Okay, so let's go ahead and get started. We'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. So if you recall from the C# Fundamentals for Absolute Beginner series that was posted on Microsoft Virtual Academy and Channel 9, near the end of that series, I wanted to demonstrate the idea of events. And to do that, I created two apps. One was an ASP.NET Web Forms app, and the other was a WPF, or rather Windows Presentation Foundation app. And I took the same basic steps to create those two apps that essentially did the same thing. A button, you click on it, and it will display a message in a label control or a text box or whatever the case might be. All right. And so what I wanted to do in this lesson was to, as a means of getting started, to give us a concrete footing that we can continue and move forward with, I wanted to recreate that example, but for the Windows Phone. And so I want to make sure before we get started that you already have the Visual Studio 2013 Update 2 installed, which will include the Windows Phone 8.1 tooling like we talked about in the previous lesson. If you already have that installed, then we're ready to move forward, and what I'll do is begin by creating a new project. And so, first of all, when we're creating a new project, we'll want to make sure to drill down to the C# templates, Store App templates, and specifically the Windows Phone apps templates. And I'll choose the blank app template and call this Hello World, and then click OK. Immediately, I'm going to want to open up the mainpage.xaml from the Solution Explorer, so I'll just double click it, and you'll see that it brings up a two-pane designer. On the left-hand side is a representation of all the XAML that is created on the right-hand side. We've learned a little bit about XAML from that C# Fundamental series. I didn't talk about it much, but we're going to get into it in much more depth in the next lesson and beyond. All right, so just so you can see the entire visual output, you can see that if I reduce the size down to 40%, we can see the entire Chrome around the phone, and then obviously the layout here. And so what I want to do is duplicate the basic steps to recreate the example that I spoke about a moment ago. I pin down the toolbox, and I'll drag and drop a button to the design surface, and then also a text block, not a text box, a text block. And we'll learn about the difference between these two in just a little while here. But as you can see, we have an on-screen representation, and when we drag and drop from the toolbox onto the designer surface, we also have the benefit of seeing the XAML that represents it. Now I'll go ahead and unpin the toolbox and get rid of it. That's all we really need for at the moment. And I'll also reformat some of the XAML that was created so that it fits more nicely onto our viewable area here. And the very first thing I want to do is actually change the name of the button to Click Me Button, and I want to change the content to say Click Me as well. You can see by making those changes, it adds and changes the appropriate attributes in the XAML. I'll do the same thing for the text blocks, which I'll just rename Result Text Block, and I'll change the text to just be empty. Save that. Now what I want to do is wire up an event handler for the button. So if you recall from the C# Fundamental series, I will select the button, whether on the more visual designer surface or the XAML designer, and then I'll click the little lightning bolt icon in the properties window, and I'll find the click event. It should be at the top, and I'll double click in the white box that's next to it in order to create the click me underscore button or click me button underscore click event handler stub. Great. And so now what I want to do is type in result text block dot text equals hello world. I want to make one more change to our main page.xaml. I could go back to the properties window and change the text here to change the font size. That's one option. I could select and change to 48, or I could just type in font size equals 48 as an attribute of the text block. So now the text should appear much larger whenever we actually run the application. Now when I run the application, notice that the run debug little icon or toolbar option actually talks about an emulator 8.1 WVGA 4-inch 512 megabyte. We'll talk about what that is in a little while, but I'm going to go ahead and just click that for the moment, and it'll take me a moment for the emulator, which is actually looks exactly like a phone except represented by software. The phone's operating system seems to load up inside just nicely. Now our app is loading, and you can see the click me button. And whenever I click it, I get the message hello world. All right, and we'll talk about the various buttons and things of that nature that are available on the phone, but you can see that I can use all of the physical buttons on the face of the phone just like if I were to have my Lumia 920 in hand, and it almost all works. There are some small differences between this software version and a physical version of the phone, but not enough to really matter for the moment. Okay, so hopefully you can see the relationship between the things that I did on screen when I was developing the app and how it manifested itself in the emulator as we ran and debugged our application. So there are some key takeaways from this lesson as we're getting started. First of all, you're going to be able to leverage your existing knowledge of creating user interfaces in Visual Studio and apply that to creating Windows Phone apps. It's easy and it's fun, and certainly there's a lot to learn here, but there's nothing to be intimidated about. We have the option of making changes in the most visual way by dragging and dropping items from the toolbox onto the designer surface. We see how that created this XAML syntax, which looks very much like HTML. We'll learn more about this mysterious XAML syntax in the next lesson. It's easy. And we can also make changes in the properties window to modify the various attributes of the controls that we see on screen. Furthermore, just like the web forms that we learned about, ASP.NET Web Forms, and the Windows Presentation Foundation, every screen, every page has a code behind that's associated with it where we can write event handler code to perform operations whenever the user interacts with our application in a given way. All right, and so the phone API provides this rich collection of controls and other options, classes that take care of the various functions that we can tap into as developers that are enabled by the phone. And it's similar to working with Windows applications in so much that you have classes with properties and methods and events. Some of those affect the life cycle of the app. Some affect the visual qualities, like the visual controls or the layout of the app, and then some affect the navigation from page to page, which we haven't seen yet, but we will get to in a later lesson. And so we'll talk about those in detail in just a little bit. And they'll help us to build more complex applications. The third takeaway is that, like the Windows Presentation Foundation app example from the C# Fundamentals for Absolute Beginner series, they're composed of a combination of this Xaml syntax, which looks like HTML, but has some key differences. It's a combination of that syntax and C# syntax in this code behind file, which is represented by the name of that Xaml page with an additional .cs on the end. And we can see that these are two parts of the whole. This is a class named main page, and if we look at the top of this page file, we can see this too is a class called main page. And they're two pieces that come together to create one idea, one page in our app. We'll learn a little bit more about that in the next lesson. And then finally, we ran this our application, we debugged it inside of this phone emulator. It provides a fantastic way to develop and test your apps without having to deploy it to a physical device every single time that you wanted to test some small change in your app. Furthermore, we can use techniques that we learned about in the C# Fundamentals series to set breakpoints and to debug our app in real time as it's running. And we'll demonstrate that a little bit later as well. In fact, there's so much more that we can learn about the emulator and its various options that we're going to devote an entire lesson to just that. All right, so that's a great way to start. We will talk more about Xaml in the next lesson. I'll give you a primer, a little cheat sheet, I guess you could say, that'll help you get started really quickly. All right, we'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job, building Windows and web apps at the world's best companies as quickly as possible. So in this lesson, I want to talk about the Xaml syntax that we wrote in our first pass at the Hello World app. Hopefully you could see how the XAML that we wrote, or that was generated by dragging and dropping controls from Toolbox onto the designer surface, or by making changes in the properties window, either way, how it impacted what we saw then in the XAML page or in the phone preview pane, and how the three panes kind of work together to generate the XAML, which will ultimately be compiled into a .NET assembly. So it's relatively easy to figure out the absolute basics of XAML just by looking at it. I mean, we were able to see here that we've got a grid and we've got some buttons and things of that nature. However, what I want to do in this lesson is point out some of the features and the functions that may not be obvious at first glance. And so in this lesson, we'll talk about the purpose and the nature of XAML, and we'll compare it to C#. And then we're going to talk about the special features of XAML, little hidden features of the language that might not be obvious when you're first staring at it. And my aim is that by the end of this lesson that you'll have enough knowledge so that you can look at the XAML that we write from here on out and be able to take a pretty good guess about what it's doing even before I attempt to explain it to you. Okay? So at a very high level, what exactly is XAML? Well, in the previous lesson, I made a remark about XAML that it kind of looked like HTML. That's actually no accident. XAML is really just XML, which stands for the Extensible Markup Language. And I'll explain that relationship in just a moment, but at a higher level, XML looks like HTML in so much that they share a common ancestry. So whereas HTML is specific to structuring a web page document, XML is more generic. By generic, I mean that you can use it for any purpose that you devise. You can define the names of the elements and the attributes that you need to suit your needs. So in the past, developers have used XML for things like storing application settings or using it as a means of transferring data between two systems that were never meant to work together in the first place. To use XML, you define a schema which declares the proper names of the elements and their attributes. It's kind of like the rules for my flavor of XML that I'm composing off the top of my head. So a schema is like a contract. Everyone agrees, both the producer of the XML and the consumer of the XML, to write and read XML to conform to those rules in the schema. They'll abide by the rules of the contract, in other words. Now they can communicate with each other if they can rely on a common syntax, a common language, a common name for elements and their attributes. So a schema is an important part of XML. Just keep that in mind. It's going to be important here in just a moment. XAML is a special usage of XML. Obviously, we see that, at least in this case, XAML has something to do with defining a user interface with not only positioning controls, but what type of control we want to display, and then its size, its shape, the text that might appear on that control, what happens when you click or do something else to the control, and so on. So in that regard, it's very much like HTML, right? If you're familiar with how to lay out web pages using HTML. But there's a big difference in so much that XAML is actually used to create instances of classes and set the values of properties in a declarative fashion. So for example, in the previous lesson, we created a button and a text block. Let me do this. Let me comment out the button like so. Syntax that should be familiar to you if you have used any type of XML or HTML syntax. The open angle bracket, exclamation mark, dash dash to open a comment, and then the dash dash close angle bracket to close the comment. Now this code between those two delimiters will not be compiled. All right, it'll be ignored. You can see that our button has disappeared from the designer instance on the left-hand side. So now let's go to our main page.xaml. And, well, actually, one other thing that I want to do here, I'm going to give my grid a name so that I can access it from my C# code. So I'll give it a name equals my layout grid. You'll see how that comes into play here in just a moment. Let me save that. All right, now in the code behind, in the main page.xaml.cs file, in this onNavigated2 section, I'm going to delete all those comments. And what I want to do is just paste in some code that I've written. And I'm going to use put my mouse cursor on the colors because it doesn't see the namespace that belongs to. I'm going to hit Control period on my keyboard and then add the using statement windows.ui. And you can see now that we have a similar button to what we've created in XAML. We've created that button now in C#. So I'll talk about the relationship between your main page.xaml and the main page.xaml.cs in just a minute. But here I'm merely writing code that will execute as soon as a new instance of this main page has been navigated to. The important takeaway is this, that XAML is simply a way to create instances of classes, and we can do the same exact thing in C#. In fact, if we run this app, I think it should work. Let me run it. And you can see it performs identically. So the XAML and the C# are almost identical. I added a background color red, and there's some other maybe size differences between the two, but essentially they're the same. However, it was much easier, or it required much less code to create the button control declaratively than creating it in C#. You'll notice that not only did I set the various properties, the name, the content, the height, and the width, but then also with the horizontal and vertical alignment, I had to use special enumerations. When it came to the background color, here I had to create a new instance of something called a solid color brush. We'll come back to that, and then give it the color I wanted to create. And here I had to manually wire up the click me button underscore click event in order to register that event handler with the click event of my new button. And then finally add the button to the children of the layout grid. All right, so quite a bit more code to accomplish essentially the same thing that I did here. All right. Furthermore, whenever I'm using the Xaml view, you can see that I have immediate feedback in this phone preview pane. I can see the impact of the changes that I made immediately, but in the case of the procedural C# code that I wrote here, I wouldn't really know what it did until I actually run the application to see how the tweaks that I've added to my code actually work. All right, so there's some benefit from a tooling perspective to using XAML over using imperative C# code. All right? All right, so if you have a keen eye, let's take a look at this right here and take a look at my button.horizontal alignment equals windows.ui.xaml.horizontal alignment.left. All right? If I change this, let's just comment out this line and change this to just quote-unquote left. All right, you can see that when I do this, I get a red squiggly line indicating that I have a compilation error. And the error is that it cannot implicitly convert type string to windows.ui.xaml.horizontal alignment. All right, that might strike you as odd whenever you take a look at the XAML that we replaced. Here the horizontal alignment equals, and here we have a string, quote-unquote left. If these are equivalent ideas, then how is it that I can just type in a string left here, but here in C# I have to give it kind of the fully qualified class name and then the enumeration value and not just a simple string property? Well, the reason is because in XAML you get the benefit of this technology called a type converter, and essentially a type converter is just a class that can translate from a string value into a strong type. And there are several of these that are built into the phone's API that we're going to use throughout the series. Now in this example, the horizontal alignment property, when it was developed by Microsoft's developers, was marked with a special attribute in the source code which signals to the XAML parser to run the string value through a type converter method to try and match that literal string left with an enumeration value, hopefully windows.ui.xaml.horizontal-alignment.left. Okay. Now, for example, if we were to just misspell the word left and leave off the T, you can see that, and actually let's go ahead and uncomment that out. You can see that I'll get an error and it'll say requested value left was not found. But if I add the T back to left, everything is just fine, okay? You get a compilation error when you have a misspelling because the type converter can't find an exact match to convert into the enumeration values. So the first characteristic of XAML is that it's a succinct means of creating instances of classes, and in the context of building a phone application, it is used to create instances of user interface elements. However, XAML is not particularly just a user interface technology. It could be used for other purposes and other technologies, and it is, like for example, in the Windows Workflow Foundation technology. All right, so let's go ahead and add left back in, and I'll go ahead and comment this out just to here again, because I think we're going to use it later. All right, so let's take a look at the very top of our XAML page. You can see we have this open angle bracket page, and even though all the properties or the attributes of that element are actually moved to separate lines, you can see that they are all one long element. It's just for readability's sake that they're moved to separate lines. And then the end page tag is at the very bottom. So it is the parent for the main page.xaml. So while you're looking this over and you take a look at some of the things that are, for example, in lines number 3 through 7, you'll remember what I said a moment ago about schemas being a big part of XML. And so if that's the case, then where does XAML promise to adhere to a schema? Well, that's the purpose of lines 3 through 7. There are 5 schemas that this main page.xaml is promising to adhere to. Each of them are defined with an XML-NS attribute, I guess you can say, prefix. The first XML-NS, or namespace rather, is defined in line 3. And you can see here that it is the default namespace. In other words, there's no colon after the word XML-NS like you see in lines 4 through 7. And the rest of the namespaces in lines 4 through 7 will use that name colon combination. So just to be clear, for example, the X, so XML namespace colon X is the namespace that's associated with that specific schema. Each element and attribute in the rest of the main page.xaml must adhere to at least one of these schemas. Otherwise, the document is said to be invalid. In other words, if there's an element or an attribute that's expressed in this XAML that's not defined in one of those namespaces at the very top, then there's no guarantees that the compiler, which is the program that will parse through our source code and create an executable that will run on the phone, there's no guarantee that the compiler will be able to understand how to carry out that particular instruction. So for example, in this example here that we've commented out, we would expect that let's take a look at the text block here. The text block element, we would expect it to be part of this default namespace because it doesn't have any letters like, for example, D colon or MC colon or local colon in front of the word text block. However, if you look at the name property, it has an X prior to it, and we know that will be defined, or the rules for it are defined in this namespace, schemas.microsoft.winifx/2006/XAML. All right. So I have a bright idea. Why don't we try this and see? Take a look at this definition so that we can understand a little bit more about it. So I'm going to copy that URL and paste it into my web browser, and oh no, it says the web page can't be found. Where is it? Well, the schema doesn't actually exist at that URL. That's because the schema is not published in the sense that you can go to that URL and view it like we just tried. Instead, a schema is simply a unique name, similar to how we use namespaces in C# to identify two classes that might have the same name. So the schema, and therefore the namespace in our XAML, keeps class names sorted out, kind of like our last name or our surname. To borrow again from that C# Fundamentals series, my last name is Tabor, and even my middle name is Theron, and so that will help to narrow down the possible Bobs that you might be referring to. Which Bob likes coffee? Remember that example? Robert Theron Tabor likes coffee. Oh, I know that guy. All right, so it's a way of disambiguating the names of classes that might be used inside of your code. So what's the fundamental difference between these two namespaces? It's subtle, but the second schema that's defined here, on line number 4, defines the intrinsic rules for XAML in general. The first schema in line number 3 defines the contract, or rather the rules for the phone's specific usage of XAML. In other words, the fact that we can work with the grid and the button and the text block and the other XAML elements without using a prefix means that they're defined in the default namespace. In line number 5 here, we have XML namespace :local, and this is just the topmost namespace for our project. So any custom classes that we were to create as we add them to the Solution Explorer, and we want a reference from within our XAML, we can just append the local : namespace in front of it and then use it inside of our XAML. And then finally, lines number 6 and 7, :D and :MC, define namespaces and schemas that we use to allow Visual Studio's phone preview pane here on the left-hand side to display properly. These instructions are ignored at runtime. That's why you see this MC colon ignorable equals D. That means anything that's defined in MC, you ignore it whenever we are actually compiling and running our application. All right, so it's purely for the purpose of the designer, not for the purpose of actual compilation. And we'll see where that comes in as we're working with dummy fake data later on in the series as we're looking at binding to data to display in our app. Okay, and so I know I've left probably some big questions unanswered here. We could spend a lot of time talking about the specifics, but the main takeaway is that our code, or this code that's at the very top of our page, defines the rules that your XAML code must follow. You almost never need to modify this code, but if you remove it, you could potentially break your application. So I'd encourage you to not fiddle around with it just yet until at least you have good reason to. And we will add some attributes to the page later on in the series. And then that final attribute there, background equals, and then this open closing curly brace syntax, theme resource with this name, application page background theme brush. We'll talk about that at length in an upcoming lesson on themes and styles. So just let's put a bookmark in that thought and we'll come back to it a little bit later. All right, I want to work more on or talk more about the relationship between this XAML file and this .xaml.cs file. All right. So you can see in the Solution Explorer that these the XAML pages have a little arrow next to them, which means that you can drill down. And so you see that there's this relationship between the main page.xaml and main page.xaml.cs. All right. Furthermore, if you look at the C# or the .cs version of this file, you'll see that at the very top it defines a public partial class main page that derives from page. All right. So the key here is partial class main page. And if you take a look at the other half of this equation, you can see here is the page class, and here we're creating a class called hello world.mainPage. Hello world is going to be the default namespace because of the project name hello world, but the class name is main page. All right. So while it doesn't use that term partial anywhere here, it's like its procedural counterpart that we just looked at, it does indicate the relationship between the two. Now, why is it important that I point out that these are really connected together by the class? And you can even see here, this name has this keyword partial. Well, the relationship means that the compiler will combine the output of the mainPage.xaml and the mainPage.xaml CS into a single class. So this means that they're two parts of a whole. And that's an important concept, that the XAML gets compiled into intermediate language, just like C# gets compiled in intermediate language, and they're both partial implementations of a single class. So this allows you to create an instance of a class in one file and then use it in another file, so to speak. This is what allows me to create an instance, for example, of the button class like we did here that I've commented out, and then be able to reference it or utilize it from this code behind here in the mainPage.xaml.cs. And we're going to see more examples of this a little bit later on in this lesson. Back on our mainPage.xaml. Since XAML is essentially an XML document, we can embed elements inside of other elements to kind of connote containment or parent-child relationships. And we've already seen this example, right? We have at the topmost level a page here owns a grid, and inside that grid we have a button and a text block. Or perhaps more correctly in XAML parlance, that page's content property is set to an instance of the grid class, and the grid has a property called children, and these two classes are added as children to the grid control that we added. All right, so depending on the type of control that you're working with, the default property can be populated using this embedded style syntax. So let me go ahead and uncomment this out again. All right, so in this particular case, I can set, as you can see, the content equal to click me, or if I wanted to add a second button and use a slightly different style, I can do this. I've added a second button now, but notice that instead of a self-enclosing element syntax, I have a open button element and a closing button element, and then between them I just have the text hi. And since content is the default property for the button control, I can just type whatever I want here and it will attempt to put that inside the content property for my button control, right? Like so. So that's default properties. In some cases, merely setting attribute values masks the complexity of what's really going on behind the scenes. And a good example of that is, for example, if we were to take this button and set the background equal to red for this button, let's do that. We can see that we can change the background of our button to red by merely, again, setting it to this quote-unquote red, this literal string value of red. All right, but if you take a look at the equivalent code here, let's comment this out and move this back up here, like so. If you take a look at the equivalent of that line of code here in C#, we can see that I'm setting the background to a new instance of a solid color brush, giving it an enumeration of type windows.ui.colors, and the enumeration value is red. All right. So this is another great example of a property type converter that we learned about earlier in this lesson. But some attributes are simply too complex to be represented in this manner using this style right here. All right. So when a property is not easily represented as a XAML attribute, it's referred to as a complex property. So to demonstrate this, what I'm going to do is actually remove that background color like so, and I'll actually remove the word hi, and I'll just put this as a content equals hi. Okay, so we can keep our eye on that. And then what I want to do is actually, the easiest way to illustrate this is using the properties window. I'm going to go to the brush settings, and I want to make sure that the background is selected, and I'm going to select the gradient brush tab in order to change the values inside of this. And what I want to do is move the selector all the way to the upper right hand corner like so. And you can see how this affects, let me change this to like 100% here, and then move around. You can see how this affects the background color of my hi button. All right, I have a gradient from red at the bottom to black at the top. Furthermore, if you take a look at the XAML that was generated from the changes I made in the properties window, you can see that we have this button.background, and then we're creating a linear gradient brush with some attributes of starting point and an ending point, and then a few gradient stops. All right. This is called the property element syntax, and is in the form of the name of the control, in this case button, and then the name of the property, like background in this particular case. And so a good example here is the linear gradient brush. The term brush means that we're working with an object that represents color, or a series of colors like we have here, from one color to the next, from black to red, from top to bottom. So I like to think of the term brush like a paintbrush that you would paint a wall with. This particular paintbrush will create a gradient that's linear in nature. It'll just evenly distribute the colors between black and red in this case. Now, admittedly, you'd never want to do what I'm doing here in this code example because it goes against the aesthetic of Windows Phone 8 applications. I don't think gradients are a really good background color unless you have a really good reason to do that. But let's pretend for now that we're expressing our individuality by using a gradient color as the background color for a button. So as you can see, if we want to define a linear gradient brush, we have to supply quite a bit of information here, right? But even this is a shorthand version. Like, let me paste in what I think will actually work here. I'm going to paste in some code like so, and nothing really changes as far as the visualization of it, but this is a more correct or the actual full definition for that linear gradient brush. I was able, you'll notice that a lot of things are omitted from this version right here to this version here, okay? So why were things like the gradient stops collection and so forth omitted in the shorter version? Well, this is done for conciseness and compactness, and it's made possible by an intelligent XAML parser that, in this case, is built into Visual Studio, but also is built into the compiler. So first of all, the gradient stops property is the default property for the linear gradient brush. So since it's the default property, you don't even need to use that. So we can just eliminate that from here and from here. All right. Next of all, gradient stops is of type gradient stop collection, which implements iList of t, and the t in this case would probably be of gradient stop, this object that we have defined beneath it. And so given that, it's possible for the XAML parser to just deduce what we're trying to do here, and therefore we don't have to be so explicit in all of those additional, the name of the property element syntax and the name of the objects. We can just give it, say linear gradient brush, and give it to gradient stops, and it knows, oh, you're trying to create a collection of gradient stops where the red begins and the black ends, essentially. Okay. So the moral of the story is that XAML allows us to create instances of classes declaratively, and we have a granular fidelity of control to design user interfaces using XAML. But even so, the XAML parser is intelligent, and it doesn't require us to include redundant code, so we can shorten things as long as it has enough information to create the object graph correctly and to represent the idea on in a visual sort of way like we've done here, then it should be just fine. Okay? So to recap, we've learned a lot about the syntax of XAML. Most of XAML is pretty straightforward, but there's a few things that were not quite as obvious, and hopefully they are a little bit more obvious now. So first of all, just keep in mind that XAML is simply an implementation of XML, and it relies heavily on schemas and namespaces to adhere to contracts so that different applications can create, interpret, and display or compile XAML code. And that's the reason why we have all these namespace declarations in the page element itself. Secondly, the purpose of XAML is to allow for a compact, concise syntax to create instances of classes and set their properties. And so we compared the procedural version of this page, or essentially the button here that we created in C# versus the declarative version of the button that we defined in XAML, and we can see how much more concise the XAML version is. Third, XAML requires less code due to its built-in features like property type converters, allowing us to just use literal strings instead of the full class name, including all of the namespaces that lead up to that class or that enumeration. And it allows us to do things like we saw here with default properties and to infer certain things about our object graph that we don't have to define explicitly, like we just talked about here near the end, for complex property settings. And we learned about the embedded syntax style and the embedded nature of elements, which suggests relationships between visual elements. So here we can see that the button and the text block are children of the grid control. So we would expect there to be a children property, which is a collection of UI elements, okay? And the grid is a child of the page itself, all right? And then we also talked about default properties. I think I just mentioned that a moment ago. All right. So next up, let's take a look at the grid control for layout. We've done some pretty simple things here, just using margins and alignments, but let's talk about that in more depth in the next lesson. And we're also going to talk about XAML's attached property syntax and how events are wired up in the very next lesson, so we'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. In this lesson, I want to talk about layout, in other words, how controls are positioned and arranged on your app's user interface. And so my game plan goes like this. We're going to start by talking about the two primary elements that are used in layout for phone apps, specifically the grid element and the stack panel element. With regards to the grid element, I want to talk about how to define rows and columns and talk about the various sizing options and techniques that you can use to get the most from the grid control, the grid element. And then with regards to the stack panel element, we're going to discuss how to change the orientation of items that are stacked next to each other from horizontal to vertical, and also talk about the alignment of items as well. And then finally, what I want to do is kind of switch directions a little bit and talk about how event handlers are wired up from both XAML and C#. We've covered this in the C# Fundamental series, but I want to recap that and talk about it one more time just to make sure that it's solid in your mind before we continue on. All right, so let's begin by talking about the basics of grids. The grid element is used for laying out other controls. It allows you to define rows and columns, and then each control that you embed inside the grid can request which row and column that it wants to be placed inside of. So whenever you use the blank app template, as you see I have here, and I haven't made any changes to it just yet, you're provided very little in terms of guidance to get started with. You just have an empty grid. No attributes set on the grid, nothing. So let me start by pasting in a name for this grid. You only have to give XAML elements a name if you are planning on referencing them from other XAML elements, or if you're planning on referencing them in your C# code. And I'm using the name layout root. It's a common convention that's used in the other templates that we'll see upcoming in this series. Now, it appears that there's no rows or columns defined in this grid. However, by default, there's always one row and one column, even if it's not explicitly defined. And these make up the full vertical and horizontal space available, and it represents one giant cell in the grid. All right, so any items that are placed between the opening and closing grid, like we saw in our previous examples, they're understood to be defined inside of row 0, column 0, that implicit row and grid definition that you don't even see defined here. All right. So let's talk about how to define rows and columns. Let's take a look. Let me actually just close this down. We don't need to save anything. And let's open up this project. You can find this project wherever you're currently viewing this video. There should be a download link somewhere on the page, probably underneath the streaming version of the video, maybe beneath the little paragraph description of the video itself, maybe some links in there. Okay, make sure you download all the source code available for this series. Inside of the what is this, lesson number 4 folder, there will be a number of projects. Open up the project that is called row definitions, and you can see here that I have a simple grid with 2 rows defined here in a grid.row definitions, that property element syntax that we talked about in the previous lesson. And so as you can see, we defined a row definition with a height of auto and a row definition with a height of star. Now there's a third option as well where we can define the actual number of pixels. In fact, if you take auto and change that to like 200, for example, you can see that it will create the height of the row to 200. Now, let's remove that and move it back to auto, but take note that there's some black lines above and below that, that beige bar at the top. I'm just going to return this back to auto. That beige bar at the top is actually a rectangle element, a rectangle object. and we set its height to 100. Therefore, when I set the row definition's height to 200, it left plenty of empty space, and it centered that beige rectangle in the middle of that empty space. All right, so that should give you some clues as to how things are laid out by default inside of a grid. They're going to be centered within their height or width or whatever the case might be. Notice that we're not giving a width. That implicitly states that use up the entire space that's available. I could change this and set the width to 100, and you can see now that the width of the rectangle is basically, it's a 100 by 100 rectangle, giving plenty of room on the left and right hand side. Notice that it has been by default aligned in the center of that row definition. All right, but let's go ahead and remove that and get back to its original state here. All right, notice that I have assigned this rectangle to row equals 0. I didn't even define grid.column equals 0 because, again, that is implicit. In fact, I could leave this definition off here and this would still work correctly. I'll just remove it and nothing will really change because I didn't have to explicitly state which row that I was going to put this rectangle in if it's in the very first row in grid.row equals 0. All right. So a lot of ideas there floating around, just the defaults and the nature of why Xaml is great is because you don't have to define each and every little thing. It will just give you the defaults and get you close to where you need to go without having to make a lot of changes. But notice that what is defining the height of this row? We set it to a specific pixel count of 200 a moment ago. I could set it to a specific pixel count of 100. However, the word auto here, it means that take all the items that will be inside of this row, calculate the height of those items, and then use that as the height of this row. And so that's how it works. It sees that there's only one item in that row. The height of that one item is 100. Therefore, make the height of that row 100 because we set it to auto. The second item, you can see here that the height is set to star. And we'll talk more about star sizing in a moment, but that says use the remainder area that's available. So if this is only going to be 100 high, then the second row will be all the rest of the space available because of the asterisk, the star sizing. And we're just setting the second rectangle into the second row, grid.row equals 1, and then giving it a fill color as well. All right. Let's talk more about star sizing because you have some other options there. So I'm opening up a new project called star sizing. You can see here I've defined 3 rows and 3 rectangles. A red rectangle, blue rectangle, green rectangle set to row 0, 1, and 2 respectively. Also, take a look at the row definitions. I have a 1 next to the star here, a 2 next to the star in the second row, and a 3 next to the star in the third row. Well, this basically is saying, give me a share, or give me 1 share of the height that's available, give me 2 shares of the remaining height available, give me 3 shares of the remaining height available. So the layout engine will take all of that into consideration and determine that there will be 3 rows and that there will be essentially 6 shares to be divvied up, 6 shares of height to be divvied up between those 3 rows, and then give them 1 share, 2 shares, 3 shares appropriately. And then we're merely just putting our rectangles in each of those rows, and they'll fill up the height. Since we didn't define a height or a width, they'll fill up that entire space inside each of those rows. All right. Let's open up one more example here and take a look at this project called Grid Rows and Columns. And here what I've done is created 3 rows and 3 columns, each with star sizing. So just take up an equal amount of width and height, okay? And so we have, as a result of 3 rows times 3 columns, we have 9 cells, and I've just placed the number 1, 2, 3, 4, 5, 6, 7, 8, 9 in each of those cells. Now, you'll also notice that I did this with a text block. This first text block does not set the grid column or the grid row, and that would infer what? to be implicitly placed in the first row and the first column. Additionally, take a look at number 2. I'm only setting grid.column equals 1. What does that mean? Well, it means that's implied that grid.row equals 0 and the column would equal 1. And so you see that continue on here. Like, for example, number 6, we're setting both the row and the column. The second row, the third column, 1 and 2 respectively. Okay? All right, let's move on to another example. This one is called alignment and margins. And you can see here that I've created a series of rectangles. Notice that I haven't created any rows or columns, that there's just the implicit row and column to create one large cell in the middle. And so most of this example should be obvious if you stare at it for just a few moments. But there's several finer distinctions that I want to make about alignments and margins. First, this example points out how vertical alignment and horizontal alignment work even in a given grid cell. And the same will hold true when we talk about stack panels as well. The alignment, whether it's horizontal alignment or vertical alignment attribute, will pull controls towards their boundaries. By contrast, the margin attributes, like you see defined in some of these latter examples here, they will push controls away from their boundaries. So that second observation is the odd way in which margins are defined as a series of numeric values, like you can see here, separated by commas. It's a convention that's borrowed from cascading style sheets. The numbers represent the margin pixel values in a clockwise fashion starting from the left side. So in this case, take a look at this yellow rectangle. Margin, so we're setting the alignment to the left, so that will pull the rectangle to the left, and the alignment, vertical alignment is set to the top, so it will pull the alignment of the yellow rectangle to the top. Then margins start to push things away. So we'll say push the margin 100 pixels from the left out. So we pulled it to the left and now we're pushing it back out 100 pixels, and then the second value will be to the top. We have pulled the vertical alignment of that yellow rectangle to the top. Now we're pushing it down 100 pixels. And so the same thing is true with this second example here. Remember, we're starting on the left side and working our way around with these values. We are pulling to the left and bottom, so left and bottom, but then the margins will push the white rectangle 50 pixels out towards the center, and then it won't push the top or the right, but it will push from the bottom margin, from the bottom of the viewable area up 50 pixels based on this last number 50 down here. Okay. Okay, so if you take a look at one of the previous examples here, let's take this one for example. Notice how I'm using star sizing, or if we go back to take a look at this example, we're using auto and star sizing. It's generally preferred that you use auto or star sizing to lay out the controls in your app. Resist the urge to set heights of rows or widths of columns in absolute pixel values, because you don't know the screen size of the device that your application will be running on. Some phone screens have wider or taller dimensions than other phones, and therefore if you use a more relative type of sizing, you'll get better results and your apps will more likely lay out more nicely given every screen size that's available on the Windows Phone. Having said that, when you're working with margins, however, you'll be working with absolute pixel sizes like we've done here. All right, why is that? Well, margins are expressed in exact pixels because they're usually just small values to provide spacing or padding between two relative values, and can therefore be a fixed value without negatively impacting the overall layout of the entire page. Okay, so we've talked about grids, how to create rows and columns, how to set their widths and heights, how to use relative spacing for the widths and the heights of rows and columns, and then how to use absolute pixels for margins. What we want to do now is change our discussion over to the stack panel, which is the second way to lay out a given to lay out the controls on a page. All right, so what you see on screen is a slightly more advanced version of the stack panel. We'll come back to it in just a moment here. At a high level, a stack panel is pretty simple. It's just going to allow you to arrange controls that will sit next to each other in a vertical fashion or a horizontal fashion. So it's just think stack panel, think of things stacked up in a flow-like structure, either from top to bottom or from left to right. All right, and so when you keep that in mind, all we're really doing here is using, in this more intricate example, a series of stack panels. So we've defined one stack panel that has one rectangle, and then next to it another stack panel. All right, which defines additional stack panels and rectangles. But here, this topmost stack panel is set to horizontal, so we're going to stack from left to right. And so this first rectangle will be on the left-hand side. It'll have a width and a height of 200, and it'll have this bisque color. Next to that is the second stack panel, which we've set the orientation to vertical, meaning inside of this area here, we'll start from top to bottom. Notice that this stack panel's orientation is set to vertical, but then it's followed immediately by a stack panel with an orientation of horizontal, which says we're basically going to create two stack panels that will be stacked on top of each other. So we're talking about a row here of these three at the top, and then a stack panel, a row with these three stack panels, or rectangles rather, at the bottom. All right, so this first row of stack panel is going to be set to horizontal. Therefore, the first rectangle will be set as this azure color right here. Next to that rectangle, there's another stack panel that has its orientation set to vertical, so top bottom, with this rosy brown on top and this dark cyan color on the bottom. And then the same is repeated on that second entire row here. We are going to work horizontally, so from left to right. The first one will have this tomato color right here, and then next to it will be a stack panel that will stack the next two rectangles vertically, burley wood and saddle brown. All right, so two different brown colors, and hopefully you get the idea there. So I would recommend that you take a few moments and attempt to match up the stack panels and the rectangles to see how this example is produced. If you think in terms of rows, and there's a rectangle and a stack panel next to it, and that stack panel may contain other rectangles or stack panels, and just try to parse through it, change the colors, and see if the rectangle you thought the color you would change, like you can change this one to red, right? Is that the one you thought? Yeah, it is. Okay. That will help you understand better how a more intricate stack panel layout would work. So as we continue through the series, I'm going to use multiple stack panels, maybe nothing quite this complex, but I'll use them to organize the various Xaml controls on screen. In fact, I've grown to the point where I prefer to use the stack panel because I feel like more flexible than the grid is. However, I started off thinking very rigidly in terms of layout with the grid, and so that might be a natural place for you to gravitate towards. And so I guess this is just a personal preference. All right, so let's move on and talk about the last topic here, and that is events. If you watch the C# Fundamentals series on Channel 9 or on Microsoft Virtual Academy, in one of the last videos I talk about events. In the Windows Phone API, pages and controls raise events for key moments in their life cycle or for interactions with the end user. Now in this series, we've already wired up a click event of our Click Me button with a method that I called an event handler method. So when I use the term event handler, I'm really just referring to a method that is associated with an event. I use the term wired up to mean that the event is tied to a particular event handler method. So some events can be triggered by a user, like the click event of a button or the tap event. All right. Other events happen during the lifetime of the app, like the loaded event that occurs after a given page or control object has been instantiated by the runtime. And there are two ways to wire up an event for a page or for a control to an event handler method. Now, the first is to set the given event using the attribute syntax of Xaml. So let's go ahead and just create a new project, new blank app template. We don't even have to give it a name. I'll throw this away. But what I'll do, just to kind of explain what I'm talking about here, is I'm going to add a button quickly to the design surface. And when I want to add an event, let's move this over. All I need to do is, for example, type the name of the event, for example, click equals, and then we get a little helper menu below that, allowing us to define a new event handler. Now, the way XAML works is that your elements don't have to have names. You only need a name for a XAML element if you're going to reference it from the code behind. So before I actually create this name, well, let's go ahead and do it both ways. Click equals, and then I'll just say, go ahead and create me a new event handler. I don't care what the name of it is. Bam, it'll just give me button underscore click. If I want the name of the button to be a little bit more specific, and so x name equals my button, something like that. Now whenever I go to the click equals, I can still choose that previous method stub called button click that was created last time, or I can create a new event handler, and this time it'll have the name of the element underscore the name of the event, which is the format I prefer. And so then when I right click on that name, I can go to definition, and now I can start typing inside of that event handler method. Okay. Now, as we saw in a previous lesson, another way to wire up an event to an event handler method in Visual Studio is to make sure your mouse cursor is somehow selecting either the button control in the designer or in XAML. Go over here to the events tab or button of the properties window, and then double click inside of a given event name that you want to handle. And then you can see it once again created the my button underscore click event. The final way, and we'll just go ahead and remove this click event like so. All right. The final way that we can wire up an event is through imperative code. So what I can do is my button, which is the name of our button, dot click, and I can do plus equal and then tab to generate both the name of the I guess the delegate, the name of the event handler that we want to bind the click event to. So if I were to have two buttons, let's add a second button here. Let's see if I can just drag and drop that onto the design surface, and name equals my other button. Okay, and we'll just leave it at that. Maybe we should give it some content. Other button, and we'll set its, just drag it into place here, let it generate out the margin and so forth. Now if I wanted to, I could, my other button dot click, I can set that equal to the event handler that I've already created. So I can have two events, one from my first button and my other button, both pointed to the same event handler in code. Or I could change it to create its own new one. Let's see, I may have to type some more here to get it to plus equals, tab, tab. You can see it has created a method stub and a not implemented exception that we can comment out and remove from our app. Okay? And so that plus equal operator like we're using here, it can be used in other contexts to mean add and set. So like x plus equals 1 is the same as x equals x plus 1. And that really is true here as well. We want to add and set the click event to one or more event handler methods. Here we're saying when the click event is triggered, add this method as just one of potentially several methods that are executed whenever that event is fired. Okay, we could add additional ones as well. For example, I could go my button dot click plus equals my other button underscore click. All right, and that would work as well. Finally, we have a situation where there are two buttons that can trigger the exact same event handler method, this my other button underscore click event. So in the body of this method, how can we find out which of the two buttons or other buttons or controls actually triggered this event? Well, fortunately, the Windows Phone runtime will pass along the sender as an input parameter. So since we could associate this event with any control, the sender is of type object, the type that virtually all data types in the phone and in the .NET framework will ultimately derive from. And so one of the first things that we'll need to do is a few checks to determine the actual type of the item that was sent in. So are you a button control? Are you a rectangle control? And then we can cast this sender to that specific data type and then work with its properties. So once we cast that object, for example, to a button, then we can access the button's properties and so on to determine the exact button that was clicked to fire off our event handler. In addition to the sender, we have this routed event args E, which is used for those events that pass along extra information. And you'll see how these are used in some advanced scenarios. I don't believe we'll use them much in this series, maybe near to the end. Okay? So to recap, the big takeaway in this lesson was the ways in which we can influence the layout of pages and controls. We looked at the grid and the stack panel. With regards to the grid layout, we learned about the different ways to define the heights and the widths of the rows and columns using auto sizing, star sizing, and even specific pixel counts. We also talked about how vertical alignment and horizontal alignment will pull controls towards boundaries while margins will push controls away from boundaries. And then we talked about the different ways to wire up events to event handlers and the anatomy of an event handler method's input parameters, the sender and then the routed event args. All right, so that's all we wanted to talk about here. In the next lesson, we'll actually take a look at some of the most common XAML controls that are available to us in our apps. We'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job, building Windows and web apps at the world's best companies as quickly as possible. So we're gearing up to build our first app of significance in just a lesson or two, a tip calculator. We're going to need to use different types of controls than what we've worked with up to this point, like the grid, the stack panel, the button, and the text block. And so in this lesson, what I want to do is just take a quick overview of many common XAML controls, and then we'll pick up a few other XAML controls, phone controls, as we continue throughout this series. So what I'll do is start by creating a new project. I encourage you to follow along, get some hands-on practice building these. We're going to call this project Common XAML Controls. Click OK. And for the most part, I'm just going to copy and paste some code that I've already written and take a few moments and explain what each of these do. Now we're already familiar with, for example, the text block and the button control. So we'll start with just pasting those into our designer. In fact, let's set this at 50%. That should make it a nice size for us. Over here. And we're also going to want to open up the CS, and then I think what I'll do is just unpin this for the moment. I don't think we need any of that. Great. Awesome. Okay, so I'll paste in a text block at the very top and then a button control, and then in the click event of the button, I'll show you how to return values from a given control. So for example, if we begin with a text box control, this will allow us to input text into our app. So I'll just paste that in here. And then in our button click event, I'll set the text block equal to whatever was typed into the text box. So let's go ahead and save this and run it just to see it working. And we'll follow a similar style throughout the remainder of these control examples. So in this case, if I were to put my finger into the text box, notice that it brings up a type pad, and I can begin typing inside of it. All right, and notice that the pad is oriented for adding numbers and dashes and pounds and asterisks, and this is the input scope for phone numbers. All right, so if we want to change the type of information that we allow into our text box by changing the type of keyboard that pops up, we can just change its attribute here. So you can see that there's quite a few different options here, like the chat, which would give us some of the smiley faces and other emoticons as well. There are different languages. If I just wanted to add, for example, a URL, we see it running. You'll see how it's different from the numerical input scope that we saw just a moment ago. There's the addition of the .com button on the end and so forth. Okay. All right, so let's move on and talk about the combo box. And here I'm going to actually comment out this code, and whenever we click our button, I want to take whatever the selected item is and cast that. And you can see selected item for the combo box is of type object. We want to cast that back to combo box item and then select out the content. If we take a look at the combo box, you can see that each combo box item is a child, so a collection of items that belong to the combo box. We can also set one particular item is selected equals true, and that will be the default selection when we run our app. So we should see the second item be the default selection. All right, and it is. All right, so when I tap it, notice that it brings up this flyout that allows me to choose a different item, and when I click the button, now we can retrieve off the fourth item from that list. You notice that flyout popped up. If I were to remove, I think if we go with fewer than 5 items, that instead of seeing a flyout with all the options, we'll simply see just a drop-down list. Okay, so just note that if you're expecting to see the flyout and you only have a few items there, whoops, Control Z, let's Control Z our way out of that. You'll only see it, I think, once you get to 5 or more items. Okay, so that combo box allows you, the user, to select from multiple items, potentially in a long list on a flyout. All right, moving on from there, let's talk about the checkbox, and this will be basically just a simple true or false option. You can see the checkbox has a content property, and the content by default is displayed out to the right-hand side of the checkbox. And so to retrieve its value and print it to screen, let me paste in some C# code that will do that. Let's comment that out and paste that in. And here what we'll do is just a simple the decision operator. So if is checked is true, then we'll print out is checked. Otherwise, we'll print out not checked. Now the is checked will return a nullable bool, which for our purposes won't work. We're going to cast that to bool, so it'll have to be true or false, not null. All right, so a false will come out to be, or a null will come out to be false. So let's go ahead now and run our app.
And we'll leave the checkbox unchecked and click our button. Not checked, we'll check it and then click is checked. Okay. So hopefully this is helpful. You can see not only what these controls do, but then also how to retrieve their most obvious result as well. Okay. Moving on to radio buttons. Here, let me paste in a couple of radio buttons. All right, and so we can change this from just radio button to radio button 1 and 2. Just like the checkbox, the content is out to the right-hand side. Then if we want to retrieve which of the 2 radio buttons was selected, let's do this right here. I'll paste this in, and we'll get rid of that. Okay. Notice that each of the radio buttons have a name. My first radio button, my second radio button, and then to determine which one has been selected, we will ask it to, we'll ask is checked property, whether it's true. If it is, then we know what to set our text box to, and if not, then we can try additional radio buttons. So let's go ahead and run our app again. So this time we'll just leave all of them deselected. The value is unknown. I think I put it in the wrong place here. Let's put it into my text block instead of box. That makes a little bit more sense. Change my code here. There we go. Now let's click, okay, it's unknown, button 1, button 2. Okay, so that makes sense. Now how is it able to just determine one radio button or the other? Well, because they're in a default group. If we want to add or make 2 different groups, what we can do is, for example, here I'm just going to copy these 2 radio buttons and paste them below. And I guess I'll have to move some things around here. So 3rd radio button, my 4th radio button, I'll move the top to like, let's see, 280. Would that move it down enough? And then 320, like so. All right, and we'll say this is radio button 3 and radio button 4. Let's run it the way it is. Now that we have 4 radio button options, you can see we can pick from any of these. And notice by selecting one, it deselects the other one that was previously selected. But what if we wanted 2 groups of items? Well, we would add a group name equals second group, like so, and we'll add this to the second one as well. And now we should have 2 groups. So as you can see, we can select either one of these options here in the group that has the name second group, or the group without a group name is still in one group. Okay, so hopefully that makes sense how to work with groups. Let me comment this out because I don't want this to interfere with what I'll do below it. And let's move on to the next control. The next control is a date picker. And this will allow us to select a given date. You can see here that we have a property like the date change property that we can respond to whenever somebody clicks on a different date. However, to kind of follow along what we were doing, I'm going to ignore that for now and instead just do this. So we're going to get the current date from the date picker and then toString it and put that in the text block, like so. So now let's run the app and see how this works. Okay. We have to go ahead and create a definition for it. We'll leave it empty, but let's go ahead and run the app. All right, so now when I want to pick a new date, I can change the date from the past and into the future. And keep in mind that this makes it very convenient if you are just selecting with your finger as opposed to with the mouse. And then when you have one that you want, we can select the Done button, and now that new date has been entered here. When I click the button, it will choose or will display that date, exactly that date at this time, with the offset for my current time zone, which my time zone is -6 GMT, and so that's reflected here in this as well. And since we're working with the date, we can format it in many different ways. There's a similar control for times, so let's take a look at the time picker control. And I'm just going to paste it in below here, right next to the date control. And I'll retrieve the date in a similar way. Let's comment that out. Let's put this here. So I'm working with my time picker.time.toString. Let's go ahead and run the app. And you can see when I click to choose a time, I can choose the minutes, AM and PM, choose the hours, and then click OK. And you can see that reflected here. When I click the button, it will show me in hours, minutes, and seconds what time was selected in the time picker. Great. All right, we're also probably at some point going to use an image control, so let me go ahead and paste one in here. Now what we'll need in order for this to work is an image, and so what I'll do is open up the assets folder, and I could use one of these existing images here, but I'm going to drag and drop an asset that we're actually going to use later called sunny.png, and all it is just a simple icon of sunshine. And so in order to utilize that, what I'll do is go assets/sunny.png, and it will appear there like so. And we could set that asset, or that source rather, in code, and we would just need to provide a URI. So there's really nothing to do here. I guess I could change the source code to whenever you click the button to change the image, but I'll be describing how to do that, how to reference items from the assets folder later on. So I'll just leave it as is for now. But let's go ahead and move on from there. And I'm going to talk about the slider control. And the slider is an input control, unlike the image control, that allows me to move a slider to make different settings, and I'll show you how that works just here in a moment. In fact, let's use it with a progress bar. And so I have a special setting on the progress bar, and the progress bar is just something like how much a percentage of something complete. So in our code, if we had a long-running operation, we could show it tick off 10% done, 20% done, 30% done, and so on. I can set the maximum value and the minimum, so I can say, in this case, when the progress bar is at it's going to be from 0 to 100, and I can set the current value to 50, 70, 80, 100, so on. But in this case, what I'm going to do is use this special binding syntax, and I'll come back to this a little bit later. Let me remove that so you can see it. So essentially what's going to happen here, and we'll talk about bindings later on, but every time we move the slider, whatever the current value is will be reflected in the progress bar. So we're going to do a one-way binding from the mySliderControls value property, whatever the current slider position is, to the current value, and set that to the value of the progress bar. And so if we do this right, it will work like this. So I'm going to move, as you can see, move the slider, and it will change the value of the progress bar. Very cool. Similar to the progress bar is the progress ring, which you typically use when there's an indeterminate amount of progress remaining. So with a progress bar, there's a suggestion that you're at 50% done, 70% done, 80% done, and it gives the user some idea of how much more time to expect. progress ring is just going to say working, 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 and so the default visualization is just a ring of light that continues around in a circle. Okay, and in order to demonstrate this, I'm going to actually use a final control called a toggle button. So we'll toggle the progress ring on and off based on whether the toggle button is depressed or not depressed. All right, and so to make this work, I'm going to actually implement this my toggle button underscore click event handler, and inside of there, what I want to do is check to see the current value of my toggle button. If the toggle button is currently checked in a check state, so it's depressed, then we're going to set the progress ring to active property to true. Otherwise, we'll turn its isActive property to false, which should remove the progress ring. So let's go ahead and run that. So I'm going to toggle, and you can see the rings of light, the little balls going around and around and around, and then we will deselect the toggle button and it will disappear. So two ideas there. The progress ring is great for an indeterminate amount of progress that needs to continue on. The toggle button, great for an on-off state, as opposed to a button, which is just merely a click or a tap. All right, and so these are some of the very most common controls. Some of them, like our date picker, time picker, the combo box, employ other controls like the flyout that will display other options on another page, and when you make a selection, it'll go back to the original page. And there are literally hundreds of additional properties, dozens for each of the controls that are displayed here for specific purposes. And as we go through this series, you'll learn a few, but ultimately, if you can imagine something you should be able to do something with a given control based on your previous experience of working with the phone or with apps in general. There's generally going to be a property or way to do that. Just look through the list of properties, like for example, select one of these items, let's say for example the date, and we'll just start looking through the various categories of properties that are available there. Maybe like the specific start date that you want to begin with, or its layout, or the fonts and the colors that you want to use. Those are all various properties that are just usually hidden inside of the properties window and available for you to modify. Okay, so that's all that I have to say about the Common Xaml Controls project. Hopefully that gave you some exposure to some of these controls and you can start utilizing them in your own projects. All right, so we'll pick back up in the next lesson. We'll see you there. Thank you.
Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job, building Windows and web apps at the world's best companies as quickly as possible. So the Windows Phone operating system has a truly distinctive look and feel. And I'm not just talking about the tile-based user interface, but it also has default colors and typography that's used. And if you search online for the Windows Phone Style Guide, you'll find official documents from Microsoft that outline these styling suggestions. However, even inside of those suggestions, there's room for creative expression and branding for your particular organization or app. So you'll want to know the rules, but then you'll also want to know how and why to break them. So in this lesson, what I want to do is talk about the technical aspects of working with XAML to style your app. Now, primarily, I'm going to be creating reusable resources and styles that can be shared between many elements on the same page or all the pages across the entire application. And then finally, we're going to talk about some pre-built themes that are available that force consistency across all apps on a given user's phone. So let's start by just supposing that you have a particular color or a setting that you know that you're going to want to reuse throughout the entire page that you're working on or throughout your entire app, or a color or setting that you might want to change occasionally, and you want to make that change in one place and have it reflected everywhere where you've defined that given that resource, that color, for example. Similar to cascading style sheets, where it's kind of a layer of abstraction where you define the styles in a style sheet, and then you apply the given classes or IDs to your HTML page, and then anywhere you want to make change to how those are represented, you can just change it in one place in the CSS definition. Well, the same holds true here. In that case, you can create a simple resource and then bind to it as needed. So I'm going to create the most simple example that I can possibly think of, and I'm going to call this Xaml resources. And then I'll click OK. All right, let's open up the main page.xaml because we're going to work here. And I'll move this over and we'll reduce this down to like 40. You can see it there. And let me paste in some code that will give us something to style up. And I'll get rid of the grid and I'll just paste in my stack panel with an app name, a page name, and then a button. And I have no styles applied to this. Some default styling is given to you. We'll talk about themes and how your app is themed by default here in just a moment or so. But suppose, for example, that I wanted to define a color that I want to reuse throughout my app. So I might create a style. So I might create a resource. I'll do page.resources to kind of house all of these. And I'm going to paste in a solid color brush. I'm going to give it a key, which will be how I reference it in the rest of my page, and then give it a color as well, which in this case will be brown. So in this case, I can do something like this. I'll set the foreground property equal to, and then I will use this binding syntax of an opening and closing curly brace, the word static resource, and then I will type in the word my brush. You can see that it pops up in IntelliSense as a valid option. And when I do that, notice that the app name text block turns to brown. I can also reuse this here as the background color using the same sort of technique. So static resource, my brush, and now the background color for the brush turns to brown as well. And I can change this to yellow, and now notice that it changes both of those, or everywhere I've used that solid color brush that with the key name of my brush throughout the entire page. Awesome. All right, so the key to this is the binding syntax, which we're going to see often for different purposes in XAML. And so binding to a resource like this takes the form of the opening and closing curly brace inside the word static resource, which is the style of binding we're going to do, and then the name of the resource. So curly braces indicate binding. That first word, static resource, defines the type of binding. We're binding to a resource that's defined in XAML, as opposed to a more dynamic form of binding for data, which we'll talk about a little bit later. So beyond these simple resources that you can define, styles take it a step further. They allow you to collect one or more settings together that can be reused across a page or across an entire app for a specific control, and they allow you to kind of collect together multiple settings, not just one. Then whenever you want to reuse that style, again, you would bind to it for a given control's style attribute to that style that you just defined. So virtually every control and even the page itself has features of its appearance that can be customized, whether it be fonts or colors or border thickness or width or height or what have you. All these attributes can be set on an individual basis, sure, but if you were to use a style, you'd be able to collect those settings together and then apply them by just referencing the style name. So I'm going to paste in another little snippet of XAML here to create a new style. And you can see that I have a style defined. Inside of the style, there are three setters. The style itself is going to target a specific type of control, in this case button, so we won't be able to apply this to text blocks and other controls. Furthermore, we've given it a name called my button style. All right, you can name it anything you want to. Inside, we define now which properties will be set to which value. So for example, if I want to change, so in this case, what we'll do is, I'm going to get rid of this for the moment and come back to that in just a moment. We're going to set the style property and bind that to the static resource called myButtonStyle. And notice that it has a background of blue. The font family is Arial Black, which is a very heavy, rounded font, and then a much larger font size of 36 points. Okay. Now here's one interesting little thing that I want to point out. You can override styles or settings, the setters of the various styles by, for example, I can reset the background to yellow if I want to. Now notice that it takes precedence over what was defined in the style. So anything that's local to the control will override whatever's defined at the page resource level. Okay. Furthermore, I could bind as well. There's nothing that would stop me from using the my brush, for example, to accomplish the same thing that we defined here a moment ago. Great. Now, in this overly simplistic example, it might not be readily apparent the value of this approach. But as your application grows large and you want to keep a consistent appearance between the controls on the page and across the entire app, this will become quite handy. It keeps the XAML concise and compact, and if you need to change the style or the color for any reason, you can change it once and have that change propagate everywhere that style has been applied. So I created these local resources at the page level, as you can see here, meaning that they're scoped to just this main page.xaml page. But what if I wanted to share these resources that I've defined to my entire app? What can I do in that case? Well, I would remove them in that case from the page.resources, and I would open up the app.xaml, and I would create an app.resources like so. So application.resources, and then I'm going to cut the resource and the style that I've defined. You can see it removes the styling from the preview, and I'm going to paste them into this application.resources. I'll save it all. When I go back to the main page.xaml, look, it's been reapplied. So now the style and the resource that I've defined here are available to all pages of my entire app that I may add in the future by taking that approach. All right. All right, so in addition to the styles, there are also themes. And themes are built-in styles, essentially, that are available to all Windows Phone apps, and their color and other appearance settings are set by the user of the phone. So on my phone, right here, I would go to the settings, and then to the theme option. It's the second one at the top here, and I currently have it set to yellow to kind of match the exterior, but I can change the background from dark to light, and I can change the accent color to like orange, for example. And now my phone is themed, I don't know if you can see that, as with a light background and the orange tiles. All right, I don't like that. We'll change that a little bit later. But at any rate, now as an app developer, I can utilize whatever the user selections were inside of my app. And so let's do this. Let's, instead of hard coding in our app.xaml here, instead of hard coding the background color to blue, let's use a theme resource and change this to whatever the user has selected for the phone. Now if you look at the preview, it doesn't look like anything's changed. I think that's because I have this background overriding it. Let's remove that for a moment here. And you can see that by default, in this little preview area here, the colors will be set to dark and to blue. Now, I'm going to talk more about the emulator in an upcoming lesson, but if you want to change the accent color and the background color, there's a device window that pops out here, and we can change this to, for example, let me choose yellow, and it's currently set to the high. Let's see, high contrast? No, that's not the right one. Yes, the theme. It's currently set to dark. We'll set that to light. let's see, runtime theme will not set the okay, right. So you can see now the difference in appearance here in the little device window, the little designer window next to your XAML designer, okay? So theme resources should be leveraged to keep your apps looking like they belong on the Windows Phone, on this particular user's phone. You should resist the urge to use custom colors, honestly, and you should resist the urge to use custom fonts and any customizations unless you have a really good reason to do so. You might choose to do so to match your company's established branding elements. So for example, off the top of my head, Evernote, they have a very strong branding of that green color, or Netflix has a very strong red branding color, and so they might choose to use fonts and colors that reflect their company image that you would expect to see across many different vendors' devices and platforms, okay? So furthermore, there are built-in styles that are available to your app. So for example, if you were to change the text block and set the style equal to static resource, there's quite a few here that are defined by default, and we'll talk about these in just a minute, but I'm going to set this to header text block style, and you can see when I do that, it makes the page name much larger. All right, so there are dozens of these defined. Furthermore, in most of the templates, you can see that there's a background defined automatically. If we were to remove, here, let me change something here. Let's go back to our dark theme, and let's just change this back to the normal, whatever it was. Was it Cobalt? Yeah, I think it was. All right, so now we're back to where we were. If you were to just remove this from the page declaration, you can see that we lose a background, okay? It's just basically, there's no color applied, no background applied. So where are these defined exactly? Well, I'm going to right-click this particular theme resource and select Go to Definition. And you can see that it opens up this generic.xaml page. If I hover my mouse cursor over the tab, the Preview tab, it just popped up there. Program files Window Phone Kits 8.1 include ABI XAML design generic.xaml. All right, so I'm not going to be able to change any of these. These will automatically be implemented on the phone itself. And so by calling into any of these, I'm able to, basically take a look and see how these are defined. It's also worth noting as we go back to the main page.xaml and we take a look at the definition for the header text block style that I used here a moment ago to make the page name text block larger. If I go to that definition, it opens up that same generic.xaml file. We're jumping down much later near the end of that file here, as you can see on the right hand side, to this style that's been created. It is obviously targeting the text block. Notice that it's based on another resource called text base block style. So it borrows from the style that was created earlier called base text block style, and then it adds these additional setters of properties and values, and even binding to other theme resources that have been defined. So if we were to right click and select Go to Definition for this one, maybe I need to find it within this document. So let's see. Here we go. You can see that it's set here, and it gives the default font family size and foreground, but it's even borrowing from theme resources. Okay, so I guess the key here, what I'm trying to point out, is that based on attribute that we saw just a moment ago, and the easiest way, I guess, to get back to it would be to go here, right-click, go to Definition. So this based on attribute of a style allows you to build styles based on other styles, based on theme resources and things of that nature, and override certain attributes of those styles and add new additional settings on top of them. All right? So as I said earlier, there were different binding expressions in the Windows Phone for different purposes. The static resource, coming back here, the static resource is generally used to bind to a resource or a style that's been created by you or that is defined in that generic.xaml file, like we just saw. Binding to this theme resource as follows here, as you can see here at the top in our page element, is for binding to a theme. The last binding expression that we're going to see in this series is just simply the curly braces with the word binding next to it, and that's used for binding data. Usually that means either binding to values on other controls on the existing page or binding to an instance of an object or a collection of an object, like we'll see here in a couple lessons from now. Okay, so just to recap, the big takeaway from this lesson was the various ways that we can apply styles to our controls inside of our apps to make it look like either other apps on the phone or to bring out a certain style of branding that we want to emphasize in our app. We learned how to bind to static resources like styles and resources, and then how to bind to theme resources, which borrow from the user's selections that they make on their own phone. All right, so that's all for this lesson. We'll see you in the next one. Thank you.